when people refer to AI applications that are in the world right now, they usually talk about what we call narrow AI or weak AI. And the intent of those is largely to solve point problems, having a computer master a specific skill. The other side of it is general AI, which we are far from.
Technology is transforming how we think, how we lead, and how we win. From Intervision, this is Status Go, the show helping IT leaders move beyond the status quo, master their craft, and propel their IT vision. Welcome to Status Go. I'm your host, Jeff Tunn. AI and machine learning are all the buzz. I wrote a recent post for Forbes called A Skeptic's Guide to AI. The idea was, how is a CIO, CTO supposed to cut through the hype and get a good understanding of what is AI or artificial intelligence and what is machine learning? I had the privilege of working with two people to help me craft that article and make sense of it, because I myself am new to AI. And I'm very excited to say that our guests today were those two gentlemen that helped me with the article. They're from a company called SeyVu that was recently acquired by Intervision and now a part of the Intervision family. So join me in welcoming Ananth Gopalakrishnan and Harsha Gopianandan to our show. So welcome, gentlemen.
Thank you, Jeff, for having us.
Thanks for having us.
Appreciate you guys being on the show today, and especially appreciate helping teach me some of the differences and some of the ways to cut through the hype around this very exciting yet very complex topic. And I know today's conversation will be valuable to our listeners as we go through this. So why don't we start with Harsha, if you don't mind, just explaining in general, what's the difference between artificial intelligence and machine learning?
Yes. So as you mentioned, there's a lot of buzz and hype between these terminologies. People, for all most practical purposes, they start using those terms interchangeably.
Mm-hmm.
Today, if you look at a lot of practical applications of what we call AI, is machine learning, and but as you talk about in the article, Jeff, where the distinction comes with AI is, are we making a more sophisticated implementation, or things, is the system able to learn and adapt itself over time? And that's where some of the definition towards AI comes in. I do want to point out there is one other distinction people make, although it's not the point of our article, is AI is being covered as there is a section of machine learning, the subset of machine learning called deep learning, which is more complex implementation of machine learning. And some people define AI as deep learning. But again, I'm just pointing out different interpretations of AI within the industry.
So,
Yeah, if I can
go ahead.
just to add to that, in general, when people refer to AI, the AI applications that are in the world out right now, they usually talk about what we call narrow AI or weak AI. And the intent of those is largely to solve point problems, a specific, basically having a computer master a specific skill, if you will. The other side of it is general AI, which we are far from, but there's a lot of research going on.
Yeah, general AI is defined as this the holy grail of achieving human level intelligence.
Right. And today, when someone talks about AI in their application, what they're really talking about typically is the narrow AI or even just machine learning algorithms. Is that correct?
That's correct. When you speak in terms of AI, right, it could be machine learning, it could be rule-based methods, it could be things like natural language processing. Essentially, you can think of it as a toolkit of solutions that allow you to achieve a certain level of artificial intelligence. But like you said, most applications today use machine learning to solve problems.
So one of the things that has confused me as a layperson in this field is when someone talks about, well, we put AI into our software and it runs right on your mobile phone. And to me, I still have the notion that to do AI, to really train these models, requires a heck of a lot more horsepower than is available on your mobile device. So, what are they really talking about? Are they really talking about AI and machine learning, or are they talking about a deployment of a model?
It's so there's two distinct phases when you consider training a model using machine learning. There's the training part, which I just talked about. Essentially, this is the part where you have a set of data from the past and you train algorithms to identify underlying patterns that best describe the data and its outcomes. And then once a model is trained, now you put it into production to use it for specific prediction purposes, right? And this phase is called the inference phase. The training phase, like you mentioned, is usually quite expensive. There's a lot of iterations of training that you do, and it takes a long time. In some cases, the inference is a lot cheaper, and as a result, it's easy for it to fit within a form factor of a mobile phone and whatnot.
Is the model getting quote unquote better during this phase?
So the model, very good question, by the way. The way the model gets better is when the user interacts, through their phone or computer with the AI system. If it's implemented properly, then all the new data gets back to the training set, and over time, all that new data and new inferences uh, help the model learn and
Okay.
adapt, and that's how it gets
So it's
better.
that feedback loop that takes it back to the more robust compute power to continue to train the model.
Exactly.
Okay. So when we posted this article online, it generated a lot of conversation around the data itself. And the concept of, is more data better, or is better data better for training your model? What makes sense from your perspective?
Yeah,
Harsha, you want to take it?
sure. Yeah, the quality of the data and the quantity. And obviously, as data practitioners, we love more data. Uh, but there is a misperception that there needs to be a lot more data for developing good models, which is not exactly true. There are situations where, like you point out, Jeff, where if you have a high quality data set, but that maybe is not really big, that would still work. And so my short answer is, more data is better, but quality data that is clean. And this part of what data science practitioners do is take data, you know even it's a raw form, make all the transition transformations, cleaning
Right.
necessary to make it into good quality data. I don't know if that answered your question,
Yeah,
Jeff.
so it's more good data, right?
Yeah.
Yeah,
You're looking for both as you're training these models.
yeah, like Harsha said, we want it all if we can have it.
Yeah,
But again, it's application based, right? In some cases, right, you can, with high quality data, train with less amount of data. In some cases, more on the visual processing side and whatnot, you actually need a larger data set. So it really is case by case basis. But there are also solutions out there where, when you have, say, a limited set of data, we can use methods like semi supervised learning that is able to kind of start with data that's tagged, for example, and then kind of build on it to
mhm.
make better models and so on. So there's many ways to cut this.
So what has really happened, it seems like, in the last couple of years is this explosion around AI and machine learning, and I think what's really happened here is it's been taken out of the science, if you will, the investigation and the development. And now there's more commercial uses for it. And so, as SeyVu, you guys were involved in a lot of different projects regarding the implementation of machine learning AI. Without giving away any client names or anything like that, could you guys give us a couple of examples of where you've seen this commercialized for business use?
Yeah, we worked with an educational organization as an example of an use case. Implement a machine learning AI system that learns and adapts over time. And their specific use case was We wanted to identify spam or fraudulent applications that were coming into their system. And as we were talking earlier, the implementation we did, we made sure that the model learned and adapted with every new interaction we had with new data over time and keeps getting better. And Anand, do you want to do another example?
Yeah, there's to answer Jeff, to answer your question more broadly. There's um, any domain that we've engaged in with clients, even when it's exploratory, we've been able to identify several solutions where machine learning can be applied. And you probably see that in the industry today too. If you go across different sectors and domains and verticals, there's applications of machine learning. I mean, the broader take that I have is, where you have data, there's opportunities for machine learning. Now, having said that, we've applied, like Harsha mentioned, in an educational setting. We've done machine learning work to better identify customers. There was a company that had a lot of customers that come and visit their portal, but they had no idea on how to market them, because this company had many different market segments that they're dealing with. What made it even more challenging was the underlying product that they were selling was generic enough that it was hard for them to detect when somebody went and looked at something on their webpage, which vertical they actually belong to. So we built some solutions here. And in this case, again, we truly treat machine learning as a toolkit, because in the end, the solution that we provided them was prescriptive, that had a combination of machine learning, optimization algorithms, and some sort of prescriptive methods and so on, when we actually implemented the solution for them. We've done a lot of work in natural language processing, being able to use unstructured data like text and being able to create actionable insights from them.
That's excellent. It really begins to change the way a business operates, or it has that potential, right? So have you gotten involved in that aspect of this? Is how does having AI or machine learning help you with decisions, and therefore how does it change the way you manage your business?
Yes, and this is the most important aspect where all these sophisticated technologies and buzzwords really come, right, where the rubber meets the road.
Uh-huh.
Yeah. What we say in SeyVu, we used to say is, our goal is to take big data and then turn it into actionable insights. Not just insights, but it has to be actionable by the businesses. To be meaningful for them, with the data providing another toolkit, another important data point for business leaders to be able to make these decisions. And that is very critical. uh, Everything we do, we have a focus on solving real world problems. That's what we like to say internally, because you want to graduate from this phase of science and research into practical
Right.
applications.
So a lot of times you'll talk to leaders of organizations, leaders of companies, and they'll talk about, well, I run my business by my gut instinct. And then there's others that'll say, well, we're a data driven organization. Have you guys done any research or any study into the accuracy of leaders that manage by gut instinct versus those that manage by data driven decisions?
Yeah, we haven't per se done that research, but I think there has been enough research done. I can't.
Just was a question that occurred to me as we were talking.
No, that there has been, I think research has been done that focuses on that as ties exactly to the topic you're talking. And typically data driven decisions, maybe I'm biased here, but have been proven to be more reliable and more accurate than gut based decisions.
Yeah. So guys, let me circle back to a little bit where we started, which is this whole concept of AI washing. I remember back several years ago when the environmental cause took hold, and we got into that whole concept of greenwashing. Everything was green even though it was the exact same product repackaged. And then to bring it into technology terms, the same thing happened in cloud. All of a sudden we've got applications that are being touted as cloud or software as a service, when all they were the same applications repackaged. It feels like sometimes we have that same problem now with AI and machine learning. So, for our listeners out there, what are some questions that they can ask, or things to look at that will help them identify, is this real or is it just a repackaging of the same stuff?
Yes, Jeff. So, just to step back a little bit, the reason this is happening is because of the explosion of the need for machine learning AI talent. And I think there is some study by McKinsey or Gartner, I forget which, says that in the next few years, there's going to be maybe up to 250,000 data scientists short just in the US. And
Yeah, yeah.
yeah, and what this has done is, as you point in the article, there are developers that take open source machine learning models that's already been developed and just implement them. This is one of the problems I think you are referring to here. Some things to do, some things to keep in mind would be internally, at least what we have always talked about is this concept called foundations of data science. And while we believe the tools, the algorithms are important, very important, the equally important part in data science is the data.
Yeah,
And yeah, to be a good data practitioner, you need a lot of experience working with data, statistics, and ability to understand the data. uh, that would be one of the things maybe that you can look at. Do they have data scientists
yeah.
on staff, or the companies working with people who understand data, who work on data science. Things of that nature would be what I think.
And just to add to that, right? A few other things that you want to look for, when a company, suggests that they have a product that has AI included, is do they have the domain expertise to be able to solve that problem? A lot of times, even when we talk to organizations, we look for domain expertise as a source of how to build a solution for them. So, existence of domain expertise, the presence of data and good data, do they have access to that for us, for them to be able to produce a solution that's valuable? How scalable and secure their infrastructure is if they have a sort of a ML as a service sort of a product. And then, how do they adapt over time? We can come back to the whole idea of like real world feedback, right? Is there some sort of feedback that happens? Does the product improve over time? And these are kind of the key vectors where, if I were a CIO, I would start poking at these areas to really get a sense for whether they have an informed strategy around AI.
So it was, do they have data scientists on staff and how many? Do they have the domain expertise to solve the particular problem that they're solving? Scalability and security, as well as that feedback loop. Those were the 4 points that I heard the two of you mention. Does that sum it up as a way to start?
Yes, and one thing I'd add is, when we say data science, right? It's also, everybody, there are a lot of claims about being data scientists. One thing to think about is, again, this might be a little bit more technical in nature to understand, but ask questions around their approaches, how they approach data. Going back to this concept I earlier mentioned about foundations of data science,
Hmm.
that would be another one I could think of.
Okay. And if we're kind of interrogating, if you will, or looking into their approach towards data, what things should we be listening for that they're taking the right approach?
First thing I would say is, do they have a good process in place to be able to handle or solve a machine learning problem? The origins of machine learning are from basically, experimentation and basically from academia, right? But people have effectively converted that to real world solutions. One thing that is important is to see if the organizations have good guardrails for how they define problems, how they kind of analyze the problems, and then build models and so on. It's easy to start going into the weeds when you start looking at data, right? How structured is their approach to be able to kind of handle that process is an important aspect of it.
Yeah. So to sum it up, deep data expertise in terms of how data science is applied, combined with a systemic process that's geared towards solving real world problems.
Okay. So earlier in the conversation, you mentioned deep learning. Can you define that for our listeners? What does that mean when you've used, is that a technique that you use to train the models? What exactly is deep learning?
Well, there's this concept of machine learning which is called neural networks,
Hmm.
and it's a sort of an architecture where you have layers of neurons, if you will, and each neuron is basically doing a specific sort of a function, and it's this arrangement of neurons and their interconnection that allows you to build and learn a specific function. Now, it's what we've learned is that by stacking many such layers, behind one another, it's possible to learn really complex patterns within the data. So when somebody refers to deep learning, what they're really saying is that it's a large neural network with many layers of neurons in between. At the basic level,
Okay.
that's
Yeah.
what it
Okay.
is.
The technical definition, I think, is if you have more than one of these hidden layers in a neural network model, that qualifies as deep learning.
It's
And
deep
as a
learning.
practical example, like facial recognition, and those are some of the things of practical applications of deep learning.
Okay. Guys, this has been a great conversation. And the way I would love to leave it today for our listeners is to ask each one of you, what's one thing different that our listeners should do tomorrow because they listened to us today? Whether that's a bit of research, whether that's looking in a new area, whatever it may be, what's your recommendation for an action for our listeners to take? So, Ananth, let's start with you. What is your recommendation to our listeners?
So this is one thing I would say is, as I mentioned, where there is data, there is scope for machine learning to help solve a problem. And even when we talk to different clients, what we notice is the value of domain expertise is extremely critical here. So, for people that are listening to the podcast, what I would say is, having a baseline understanding of machine learning puts you in a position to start asking the questions that machine learning can help solve. A lot of good solutions that are coming out today are coming from people who have good deep understanding of their area of expertise and realize that, listen, I have the data to be able to solve this specific problem related to my domain. So that's what I would encourage them to start with, and then basically work with practitioners who are kind of good at building end-to-end solutions based on some of the criteria that we already talked about.
Okay, excellent. Harsha, how about you?
Yeah, I'll just add to what Anand said. There is some hesitancy to invest in machine learning AI solutions because there's a perception that there's a lot of investment needed. And one thing I would suggest is there is ways to take baby steps. Take incremental. Start with small proof of concept, small wins, and try to build from that into a more complex solution rather than trying to start at very building a very complex high investment solution, which because that's not required. That would be my suggestion, is build from small wins and keep extending that solution.
And grow it from there.
Yeah.
That's great advice. Ananth and Harsha, thank you so much for being on the program today. I think our listeners are going to take away at least some base knowledge of this mystery of AI and machine learning and deep learning. So, thank you very much for your time today. I really appreciate you being on the program.
Thank you, Jeff. It was a lot of fun.
Thanks, Jeff.
For our listeners, if you want to learn more or you have any questions, visit intervision.com. The show notes will have links and contact information for all of us involved. And we would really love to hear from you. Join the conversation and ask your questions. We would love that feedback. This is Jeff Tunn for Ananth Gopalakrishnan and Harsha Gopianandan. Thank you very much for listening.
You've been listening to the Status Go podcast. You can subscribe on iTunes or get more information at intervision.com. If you'd like to contribute to the conversation, find Intervision on Facebook, LinkedIn, or Twitter. Thank you for listening. Until next time.